If you observe a little bit more carefully, in the previous year papers of especially TOC, I have observed one pattern in which some questions, some very few selected questions, have been repeated in almost all the papers. And on top of that, those questions have been coming in same or. Hello everyone. Today's video is going to be a very interesting one because it's related to exams super important questions video. The questions which have always come in a single or. Such question exists if we analyze the previous year papers carefully. So in this video I have collected all such questions which have been in that same pattern, and I'll be discussing what similar type of questions you could expect in exam, so that you will be able to score more than 80% marks in the exam by following just these few selected questions. And subscribe to my channel for more videos like this. So without wasting any more time, let's get started. The first question in the module 1 is related to the definitions. Okay, see here, in the definitions part we have the following definitions: define an alphabet, string, language, concatenation of language, power of an alphabet. This is for 10 marks. Okay, and it has been repeated in February 22, June 23 model paper 2019, July 22 model paper 2022 for the 22 scheme, and Jan 2021. Okay, so the questions which are here, like for example, they might ask just alphabet and the string, or they might ask alphabet, concatenation of language, power of an alphabet, but most of them have among these definitions only. So it's very easy question, you can easily memorize the definition with an example, and easily you can score 10 marks. Okay, so this is a never to miss question. Let's understand each of these examples and definitions one by one. The first is, what is an alphabet? It is a set of finite symbols. Okay, it is a set of what? Finite symbols. Here we will be having 0 1. This is one set. Okay, and this is, each of these is a symbol. Okay, this is a set of binary alphabets. Binary numbers will be 0 and 1, right? So alphabet is a set of finite symbols. So whichever symbols are present here, that whole set is called as what? Alphabet. Okay, what is string? It is a finite set of sequence of symbols. Okay, there will be sequence of symbols, so we'll be combining them and forming string. This is one string, this is another string, this is another string, and so on. Next we have language. What is a language? Now we got to know what is a string. From string comes language. If we combine many of the strings and form it as a single set, we'll be getting a language. Language is nothing but a set of strings. Okay, next is concatenation at languages, combining two or more languages. For example, if L1 is equal to 1, 2, 3, 4 and L2 is equal to 11, 22, 33, 44, when we do L1 dot L2, this is called as concatenation. Here when we do that, we'll be able to combine each of these languages, and all the elements will be sorted in the increasing order. Okay, so the sorting is not important, but the thing is all of the combination will be present here. Okay, the last one is power of an alphabet, very important here. What is a power means? How many length should be there? Okay, what should be the length of string? Suppose that if I give the set of symbols as 0 and 1 and the power as 0, that means set of string of length 0. Okay, length 0 means it will be an empty string, empty set, because there will be no length, means there will be no alphabet also present here. If it is 1, 1 means string, a set of string of length 1, single length 1 and 0. If it is like this, 2, 2 means what? 1 1 1 0 0 0 0 1, right? So four things will come here. So combination of all of these will be forming the set of all the alphabets. Okay, and power of alphabet is defined as length of the string. Okay, these five definitions, super important one, don't miss any of them, and learn the examples as well. Moving on to the second super important question. This is repeated in the following papers, so you can understand how important it is. So in the module 1, firstly you need to know the definitions. Okay, definitions you need to know, and second is the designing of the DFA. Okay, you need to understand how to design a DFA. Okay, let's understand how do you do that. So the first question here is, design DFA to accept strings of A's and B's where language is W mod 5 is equal to W mod 4. Okay, W mod 5, W mod 4. What do you mean by that? Mod 5 means what? Mod 5 means if we take a number and divide it by 5, okay, if we divide it by 5, what answer we will be getting and what remainder we will be getting? Remainder we will be getting as 0. When we divide 20 by 5, the remainder will be getting as 0. So 20 mod 5, this is mod 5 is equal to 0. We will be only considering the remainder. Okay, so whatever the number is there, if we divide by 5, what remainder we get, that remainder should be equal to that same number divided by 4. Okay, for example, let's take 20 only. What is 20 by 5? 20 by 5 remainder, tell me what is the 20 by 5's remainder? Remainder is 0. The same number if you divide by 4, it is having the remainder again as 0. So w is equal to 20. Okay, that is one valid w. What is w? W is nothing but length of the string. Length of the string. Okay, how much letters it has, that is called as length. So if that word has 20 letters, in that the length is 20, that will be an accepted string in the particular language. So first we have to find out the value of L. Okay, so even 0 is also a valid one. What is 0 divided by 5? The remainder is 0. What is 0 divided by 4? The remainder is 0, right? And 1 also is possible, single letters, because 1 by 5 is equal to, remainder is 1, 1 by 4 remainder is 1. 2 is also possible, 2 by 5 is equal to 2 by 4, the remainders, right? 3 by 5 is also possible, 3 by 5 is equal to 3 by 4. So the length 0, length 1, length 2, length 3 is possible, but when we go to length 4, it will become 4 by 5, the remainder is 4, but 4 by 4 the remainder becomes 0. Here our difference happens. So we can take the lengths as 0, 1, 2, 3, and then next is 20. 20 by 4 is equal to 20 by 5. Also we can take 21. 21 by 4 is equal to, remainder is 1. 21 by 5, the remainder is 1. 22 is also possible, 23 is also possible, but 24 is not possible. When you do 24 divided by 4, it will become 6, right? I mean the remainder will be 0 because it's divisible. 24 by 4 the remainder is 0, but 24 by 5 the remainder is 4. Here it is a difference, both are not equal. W mod 5 is not equal to W mod 4 when W is equal to 24. Got the point, right? So the numbers which we have now is 0, 1, 2, 3, then 20, 21, 22, 23, then 40, 41, 42, 43, then 60, 61, 62, 63, and so on. Okay, now we have to make the DFA. Okay, so for the making the DFA, you have to first write this one. What are the possible strings are there? Okay, after I've written this one, the least string we have to take and draw a diagram. Least string is null, so we'll be writing here a q0 and we'll be marking a final state here, because the starting state only is the final state, because if no string is also there, W mod 5 is equal to W mod 4. This is accepted. Okay, so if in case there is one string, either A or B, I have to go to this state, and this is also an accepting state, because a single A or a single B is also accepted. So this will be also a final state. Next, another A, another B, double means A, B, 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 those cases. The length is 2. The length is 2 is also accepted, Q2. Okay. Next, length 3. 3 is also accepted. Length 4 is there, but it is not accepted. So Q4 is not final state, because in Q4, W mod 5 is not equal to W mod 4, right? In length 4. Okay. So we will not make it final state. Next final state will come at Q20, right? Till 19, till the length is 19, it is not accepted. Okay, till W is less than or equal to 19, from 4 till this range. Okay, till this range it is not accepted. Okay, from 4 to 19, so it is not a final state. When W becomes 20, I'll take it back to this same state again, and when it is 20, it should be accepted. Then this will be 21. If I take another A or B, 22 length, then 23, and so on. And 24 will not be accepted. Okay, this is how this diagram is made. One by one you have to do. Okay, one by one. After that, next which will be accepted, you have to take there. 19 it will not be accepted, 20 it will be accepted, so you will be taking it here. Got my point? So this is the DFA you need to make. Moving on to the second sub question, which is DFA to accept strings of zeros and ones, L starting with 0 1 or 1 0. Okay, so the condition is zeros and ones are there, and starting should be either 0 1 or 1 0. So which strings can be accepted? At least the least will be 0 1 and 1 0 only, and after 0 1 you can have n number of ones and zeros. After after 0 1 you can have 1 or 0 and number of zeros. After 1 0 also you can have n number of ones and zeros. Okay, so these are the combinations. Now least string we have to make first. Okay, so for that, starting state will be q 0, 0 will be going here q1. Okay, then 1 will be going here to q2. Got the point? 0 1, it will be accepted. 0 1 will be accepted. After that, n number of 0 and 1s. After that, 1 0 also we have to do. So this is 1, and from here this is 0. 1 0 will also be accepted. Okay, 1 0. Now we have to define for all. See, this state is defined for 0 and 1. Is this state defined for 0 and 1? No, it is only defined for 1 as of now. Okay, so for 0 state, it will go to a trap state. Why it will go to a trap state? The condition is the starting should be with 0 1 or 1 0. In case the starting becomes 0 0, it is never going to change, because starting has been become 0 0. No matter what you take, the starting will always be 0 0 only. So whenever 0 0 happens, it should go to the trap state. So in this case, first 0 will come here, and if another 0 comes in the second letter, it should go to the trap state. Same thing for 1 0 also. 1 0 only should be there. If 1 is there but again 1 came, it should go to the trap state. So this is 1 here, and if another 1 came, the trap state. After that, n number of n's and 0 and 1 will not make any difference. It will be in the trap state only. Okay, so the only accepting criteria here is 0 followed by 1 and 1 followed by 0. Okay, so this was about the DFA. See, these two things, definition and how to make DFA. There are other questions also. You can refer to my module videos, module 1 video of TOC. You can find the link in the description box. There you can go and watch the different questions I've solved, so you'll get an idea how to solve these type of questions. Okay, DFA, don't miss it. Okay, and another third question, which comes in the single or, same or it comes. Okay, these three question mostly comes in the same or. Okay, repeated in the following years. Define NFA and convert the following NFA to its equivalent DFA. Very simple question. You just have to memorize this definition. The problem is very simple. It's for how many marks? 10 marks. Okay, very important question. Now see, an NFA is a 5 tuple or quintuple M is equal to capital Q, sigma, and delta, q naught, and a. Okay, what is q? Q is a non-empty set of finite set of states. Q is nothing but all the states which we use, q naught, q1, q2. So all those states form q. Okay, what is sigma? It is a non-empty set of finite input alphabet. So sigma will be equal to a comma b, like that. Okay, delta is a transition function which is mapping q into sigma subsets of 2 power q. That means it is just a transition function. In exam, just write this much. Okay, this much is also enough. It is a transition function. Q naught is the starting state and a is the final state. Okay, as the set of final state if there are multiple final states. Okay, so multiple final states will be like, for example, if another case is here like q7, this will be another final state. So these are the set of final state that will be denoted by a. Okay, so converting NFA to DFA, okay, it's very simple here. What you have to do is, first Q naught is here. Okay, Q naught 0 1. This is the question which they have given. Okay, 0 1 in Q naught, and on 1 Q naught will be going to Q1, and on Q1 if it is 0 or 1, it will go to the Q2. Okay, the first thing what you have to do is, you have to make a table like this where you will make a 0 and a 1, and first you will just write Q naught here. Okay, these things you don't write. Okay, these things will not be there. You just have to make a table like this. Q naught is the starting set. You will write like this. 0 and 1 are the alphabets used here, so we'll be writing Q and 0 and 1 here. Okay, next Q naught on 0. Q naught, when I'm taking it as 0, where it is going? For on 0 it is going back to Q naught only, so I'll be writing a set in which I'll include only Q naught. When it is 1, when Q naught is 1, I am reaching the Q naught, as well as when it is 1 I can reach Q1 also. So 1 is defined for two possibilities, so it will be Q naught and comma Q1. So Q naught comma Q1, it will be written here. Now after writing this first line, what you have to observe is that whether any new state came or not. Q naught is already present here, that is same as this one, so no new state. But is Q naught comma Q1 present here? In this column, is Q naught comma Q1 present? Initially this is not there. Okay, initially we are just considering this one, so imagine only this much. When it is only this much, Q naught is present here, but Q naught Q1 is not present. So we'll be taking the state Q naught Q1 here, writing for 0 and 1. How do you do that? Q naught on 0. Q naught on 0, where it goes? To Q naught only. Q1 on 0. Q1 on 0, where it goes? Q1 on 0, it goes to Q2. So I'll be writing comma Q2. I have to consider for both Q naught on 0, comma Q1 on 0. That answer I'll be writing here. If same comes, you will just write it once. Okay, suppose that Q naught also went to Q2 and Q1 also went to Q2. You'll just write Q2 one time. Okay, not Q2 comma Q2. Okay, you should not write like that. That will be the wrong answer. So Q0, Q2 will be writing only once. Next, Q0 comma Q1 on 1. q naught on 1 where it is going, q naught on 1 it is going to q naught comma q1, so q naught comma q1, and q1 on 1 where it is going, q1 on 1 it is going to q2, so q2 here. Okay, after that which new state came, the new state which is coming is q naught q2, because only these two are there as of now. Q naught Q2 is not present in either of them, as well as Q naught Q1 Q2 is also not present in these two. The same set should be there, then we will ignore, but the same set is not here, so we'll be taking it separately. Now again we will take it here. Okay, why is this star? We have to put star whenever we get a set in which final state is there. In this diagram, which is the final state? Q2, and we have got a set where Q2 is present. So wherever the set in which the final state will be there, we'll put a star on that. Okay. Now after this, q naught q2 again 0 and 1, you will be getting these two states, and these two states already are present. See, q naught is already present here, and q naught q1 is already done, so we'll not take anything, but this was left, right? So this one will be taking it here, and again doing 0 and 1, we'll be getting these two states which are already present here. Okay, q naught q2 is present here, and q naught q1 q2 is present here. Now what you have to do, you have to make the DFA by using this table. How do you make the DFA? First start from here, q naught, right here as q naught. Okay, right here as q naught. Q naught on 0 where it is going? To Q naught itself. So make a self loop. To Q naught itself is going. Q naught on 1 where it is going? Q naught Q1. So you have to make a transition like this. Q1, make a circle, write Q naught comma Q1 and put it as 1 here. So when Q naught is 0, it will be staying in the same state. When Q naught is 1, it will be going to this state here. Okay. After that, consider this one, q naught q1 on 0 and 1 where it is going. On 0 it is going to q naught q2, make a new state, put 0 and q naught q2, and q naught q1 q2 it is going on 1. Q naught q1 q2, make it a new state again here, and on 1 it is going to this point. Okay. After you have done this one, as you can see, the final states are this one. The star ones are final state, double circle it. Okay. Q naught q2 and q naught q1 q2 are final state, so it's double circle it. Okay. After that, do the same for this also, where it is going for 0 and 1, where this is going for 0 and 1. Okay. After you do that, this will be the equivalent DFA from the given NFA. This was NFA, and we converted successfully into an equivalent DFA. Okay. So the difference between NFA and DFA is that in NFA we can have for the same symbol two outputs. Okay. See, for one I have one output as Q0 itself, and another output is Q1. But in DFA we'll have one single output. Okay. This is deterministic, means only one will be there. For one, only one arrow will be there, and for 0 also only one arrow will be there. For here, for 1 here, there are two arrows, one arrow and two arrow. That is called as NFA, non-deterministic finite automata. Then this is DFA, which is deterministic finite automata. Okay. These three questions are very important, the most repeated ones. So it also appears in the single or, don't miss any of them. Okay. Moving to the module 2, the first question we have is define regular expression and obtain RE for the following. Okay. This one question only, see, in module 2, I just have one question. Okay. In module 2, this is the only question. Okay, got the point, because this same question covers all the topics which are asked in the papers. First is define regular expression. Okay, you need to know the definition of regular expression. Second is you need to know how to obtain a regular expression from the English which they have given, like strings of AB, like this sentence they have given, how to obtain RE. That's the second type of question. Third type of question is how to obtain NFA with strings accept starting from string AB. All they have also asked for NFA here. NFA means, first in the fourth question they have asked just obtain NFA. Okay, that is the third type of question. Fourth type of question is obtain NFA from RE. RE is given here, we have to obtain NFA. Okay, four types of question came in the same one. So if you know this very well, there is 90% chance that you can get maximum marks in module 2. So this question don't miss at any cost, it's heavily repeated one. Okay, so what is the regular expression? Regular expression is recursively defined as follows. Okay, it is recursively defined as follows. Null is an empty language. Okay, so in regular expression you'll have to write four sentences. How many sentences you'll write? Four sentences. First is null is an empty language, and epsilon denotes empty string. Okay, empty language and empty string are different. Language consists of all the set of strings, so if there is no strings and all, it is called as empty language. Empty string means the string is only not there. Okay, the string which we write a b c, the string is only not there, that is called as empty string. A is a regular expression is which indicates language containing only A. Okay, this is a regular expression only in which only A is there. Okay, so a single letter is there. If R is a regular expression denoting LR and S is a regular expression denoting LS, we'll be having R plus S, R into S, R star. This is concatenation, this is union, this is clean star, which is self loop. all are regular expressions. Okay, two regular expression, if we do the union or concatenation or repeat it itself, that the result will still remain the uh, regular expression. Okay, so these four things you need to write for define regular expressions. Okay, next, re for a's and b's with second symbol from the right is a. Okay, from the right, second symbol should be a. Okay, what do you mean by that? Okay, see, whenever we write a string, suppose that it is a b a c c a, okay, like that, something string. Now second symbol from the right, this is the right side, from the right second symbol always should be a. Okay, so one thing you can observe, this is fixed here, this is the condition which they have given, and this is fixed. This is a means here I can have only one letter. Okay, and here I can have n number of letters, n number of letters I can have, whichever it is. So here they have given a's and b's only. Okay, a's and b's means in the last one I can have either a or b. Okay, only two possibilities I have, I can have either a or b. Okay, so I'll be writing it as such, here I'll have a or b. Okay, and here I can have n number of a's and b's. Okay, n a's and b's. Now, how do we make a regular expression from this? See, a is present here and a or b. In regular expression, a or b is written as a plus b, a or b. Okay, like that. And a will be here. And n number of a's and b's can be written as a plus b. N number means it can be 0 also. So, this will be star. Star means a or b can be repeated how many ever times? A, B, any order it can take n number of times. So, this is the regular expression here. You got my point? Okay, so this is the regular expression, you just have to write the final answer here. Okay, you'll be getting the marks. Next, re for a word with two or more letters. How many letters are there? Two or more. So minimum string will be having two letters, but beginning and ending with the same letter a or b. Okay, so it will have two or more letters, that is confirmed. So two letters minimum will be aa, because beginning and ending should be same letter, and bb, these two are the minimum strings. Okay, now it can have more letters also, so beginning and ending is fixed, so in between we have to put other letters. So other letters can be either a or b and can be repeated n number of times. Here also it can be a or b and it can be repeated n number of times. Now the answer can be either this or this, so I'll put this can be an answer, this can be answer. So if we separate it here, okay, and in between we have put, so we'll be writing here aa, and this is bb. Okay, because in between we had put, so this will be bb and this will be plus here. Why? Because it is either this answer will be there or this answer will be there. Okay, so this is my regular expression. Okay, got the point. Moving on to the third one, NFA for string starting with AB. Okay, what are the strings starting with AB? AB is there, and after that anything can be there. Cool. So AB is minimum requirement. So A is here, B is here. After that there will be a self loop with n number of A's and B's. Okay. And in NFA we need not have a definition for all the other ones. If A is defined here and a question can come, why not B is defined, not defined here? What if B will come? See, that I need not define because it is NFA. If it was DFA, I would have taken B and put it in the trap state. Why trap state? Because starting should be AB, and if starting only is B, it should go to the trap state for sure. It cannot escape, right? So in NFA, we need not define P. Okay, that is the advantage of NFA. Okay, we just have to define what is required, A, B, and n number of A's and B's. The last one is NFA for regular expression. This is regular expression which is given. So to convert this regular expression to finite automata. Okay, the other topic is also there, finite automata to re, but most repeated one is re to fa, so we'll be learning only that. Okay, so just focus on more questions of re to fa, so that you can expect that if that question comes in the exam, you will be able to solve that question in the same hour, right? So let's understand what is the procedure. So there are some rules present here. Okay, in case they ask you the theory for re to fsm, okay, they can ask you even the theory, but it's not much repeated. Still they can ask you the theory of re to fsm. You have to define the following things. Okay, three things will be there: a plus b, and a plus b can be defined as this, a star can be defined as this, a dot b can be defined as this. Now these three things is what union, this is clean star, this is concatenation. Okay, let me write this one. This is what union, this is clean star or self loop. Okay, clean star or self loop. Okay, the third one is concatenation. Okay, means joining, concatenation. Okay, now union means a or b. So I'm starting from here. I can go either this one or this one on epsilon. Epsilon means without any letter I can go here or here. If I go here, I'll be passing through A. If I go here, I'll be passing through B. So as you can observe, I can only pass through A or B, not both. Okay, that is the union. Okay, or operation. The clean star means I can repeat A n number of times. Okay, see, if I'm in this state, I went to A till this state, this is the final state. Again, I can come back without taking any symbol, and again I can repeat. Again, I can repeat. I can repeat n number of times, even 0 times I can repeat by following this path to reach the final destination by epsilon only. Okay, this is called as clean star or self loop. The third one is concatenation. In concatenation, we'll be having two letters joined together. So A, this is for A, okay, this is for A and this is for B, and both are joined. Okay, so actually you can take the B as like this only. So A and B are joined together and an epsilon is present here in bit in the starting part. Okay, so this is what the concatenation is. Okay, got the point. What is concatenation? Okay, so these three rules are there. Using these three rules you have to find out NFA for the following. Okay, now see, break this down. Okay, break this down into different parts. First part is A plus B star. A plus B star first I will write, then AA I will write. This is for A plus B star. Now let's take each one by one and see how it's happening. Okay, now see, A plus B star. First I have to make what is A plus B. A plus B will be like this. See, this is the rule. A plus B, if I put, it will be A or B here. Okay, the same diagram I will make here. After that, star is present. See, for A star it was A was present here, and a star means I have to put epsilon here and here. If it is B star, if I ask you what is B star will be B will be present here, right? B will be present here. Got the point? If it is A plus B star, okay, what will be A plus B star? A plus B star will be nothing but A plus B will be present here, and A plus B is defined as this, right? So A plus B star will be defined as this. Got the point? Epsilon and epsilon. So this will be A plus B star. Okay, got the point, right? So like that only we have to do. So I'll be just making this change back here to A. Okay, A star will be this one. Got the point? Now A plus B and star is taken. Concatenation, whenever concatenation happens, put an epsilon here and A, another epsilon A, because AA we need, so AA is present here, preceded by epsilon, and to connect it with another group, we'll be using epsilon here. Again, A plus B star, the same diagram we'll be making here also and connecting it. Okay, so this is the conversion of FA from RE. Okay, from regular expression we convert into finite automata. This is finite automata. From where we converted? We converted from RE was given and we converted into NFA, which is non-deterministic finite automata. Okay, that was about the module 2. Don't miss any of those questions. Okay, very important ones. Moving on to the third module. Okay, in third module you will be having the questions which are coming in the same or. The first one is the LMD RMD, ambiguous grammar, parse trees, all these type of questions. Okay, and in the second question we'll be having, seen, or we'll be having two questions here, two questions here, two or three questions, right? Second question or the first question which might come is CFG. Define the CFG for the following sentence they will give. You have to write the CFG. So we will learn in this video how do you solve such type of questions. First is ambiguous unambiguous grammar, second is the CFG question. Okay, so it's repeated in all of these papers. Okay, so see here, read the first question. Obtain the unambiguous grammar. Okay, see, unambiguous they have mentioned means we have to finally prove that the grammar is unambiguous. Okay, grammar is unambiguous. This one you have to be very careful, because if you think if it is ambiguous and you write it as ambiguous and prove it also, although it's not possible but still you write and prove, you'll lose all the marks. You'll lose 10 marks here. Okay, why you lose all the marks? Because they have asked for unambiguous very clearly and you proved it as ambiguous. So you did totally reverse of what they had asked. You will get 0 marks. Okay. So read the question very carefully. Obtain the unambiguous grammar for the grammar shown and get the derivation for the expression. I'll be also showing you in this same question only how do you prove it ambiguous. Okay, this question I cannot prove ambiguous because it's not possible. This is for proving unambiguous, but I'll tell you how to differentiate if it is ambiguous or unambiguous. Okay, so see, after that they have given some rules here. E is equal to E plus E or E minus E, and one string also they have given here, A plus B into E minus B. Okay, So using these rules, you have to prove that the following grammar a plus b into a minus b is unambiguous. How do we do that? First, you have to make the LMD. What do you mean by LMD? Leftmost derivation. Okay. Now, if you observe this formula carefully, it is a plus b into a minus b. Outside the brackets, this is the thing which is connecting both of them. This into this. Okay. Something into something. So it is of the form e star e. So first definition which I will be taking is the second one here. Goes to E star E. So E goes to E star E I have written. Now this E will be expanded as E in the bracket. Why? Because I want A plus B in the bracket finally, right? So bracket I have to take first, and I'll be starting from the left. Okay, this is the only main difference between LMD and RMD. In LMD, this E will become E in brackets. That I have taken the third rule. E goes to E in the brackets. Okay. After that, the third rule also says that E goes to I. Okay. See, E goes to I. Okay, that rule. So if you're not able to trace what I'm telling, see here, e goes to I, this rule is there, right? So that rule only I am applying here for this e. After this I have to still be in the left only. Okay, you might think that I can take this e and expand. No, you have to take this I until you reach the first letter in the equation which they have given is a. So until I reach a, I have to use the same one. Now I goes to a, which rule is that? I goes to a is given in the fourth rule. I'll use that rule. I'll use that rule, and I'll be writing a here. Now since this is done, I'll move to the next letter E. Now this E can be E goes to I goes to B. Okay, E goes to I goes to B. See, again a mistake I have made here. It is not E directly, it can't go to B. I have to make here first as I, then that I will go to B. Okay, this is one thing. Like that the things can miss, so you need to be very careful. Okay, so this is E goes to I goes to B. Okay, this you remember. Next, after that is done, I'll consider this one. This E also, finally this E should become what? That E should be becoming finally A minus B. Also you need to be having in the bracket. So first I'll convert E into the bracket E. Okay, so E will become bracket E, and inside this E it will be E minus C, because it is minus I need, right? A minus B. So I'll be writing E goes to E minus C. So instead of E I can substitute as E minus C. E will become I will become A, and this E will become I again, and this I will become B. So I got the final equation here, A plus B into A minus B, by using leftmost derivation. I was always considering the left should be done, next only the next one should be taken, after that next should be taken, and so on. Okay, in RMD what happens, the same thing we'll be doing. Starting is the same thing because star is connecting both of these, so I'll have to take this one, E is equal to E star E. After that I'll not expand this one, I'll be expanding this one, E. This E will become bracket E. Why? Because I need A minus B in the bracket. This same thing I'll apply here, whatever I had applied in the previous one, E minus E. And here I'll be taking right into consideration I, then this will become B, then this E will become I, this I will become A. After this E is present here, and I'll be taking into consideration for this one. This will become E plus E again from the right here also B, and this one will be E goes to I goes to A. So I'll be getting one equation here. Now this is the first step you need to do. LMD and RMD you have to write here. After you have made LMD to RMD, you have to make the parse tree. Parse tree you can make for any of those, this or this. Okay, and since we have to prove it unambiguous and ambiguous, we have to make the parse tree for both of them. Okay, how do we make the parse tree? Parse tree will start from here. First E goes to what? E star E, right? So we will be writing here E goes to E star E. Then what happened with this E, what happened with this E, what it became? Okay, that one we have to see. Firstly, this E had become bracket E, and this E also became bracket E. So seeing these two, I'll be writing it as such. Okay, those two became bracket E here. Okay, now after that this star is present here. Okay, star did not get any change, star was there like that only. Now this E became what? This E became E plus E, right? The first E in the left became E plus E. Where it became E plus E? Okay, first it did not become E plus E, it became I here, then this became A, then this E became B. Okay, I plus E first it became E, became I plus E. I think this one is also not correct, because E first becomes E plus E, then only E becomes I, right? One another thing I have missed here. E should become first E plus E, then this E should become I. Okay, that is the procedure. So E became E plus E. Each of these E became I became A and B. The sequence does not matter here, which came first or last, but what happened eventually with that letter is what matters. So eventually this E became I, this all E also became I, this I became A, this I became B, and plus was remaining as such. Like that only here also it happened. This E became E minus E, E minus E became I minus I became A minus B eventually. Same thing we will see the RMD also. In RMD also we'll start from here E and E. What this E became, what this E became. Like that we'll keep on tracing here and we'll be getting the same tree here. If you can observe, the same tree is present here and here. Both are equal. In case both are equal, it is not ambiguous. Got the point? When it is equal, equal means I have only one answer. One answer means it is unambiguous. Unambiguous means I am certain of the answer. I know for sure. Ambiguous means doubt. What do you mean by ambiguous? Ambiguous means doubt, uncertainty. Uncertainty will come when I have two different trees. Okay, which one is the right one? At that time, it will become a doubt. If it is having the same tree means there is no doubt, it is not ambiguous. Got the point? That's what the meaning of ambiguous. So you have to do it by this procedure only, LMD and RMD. Okay, and you have to prove it not ambiguous. In case they ask ambiguous, eventually you will get a different tree and you will just write, since the trees are not same, the grammar is ambiguous. Okay, next, what question they have asked? They have asked, consider the following grammar. The grammar is given here. Give LMD and RMD and parse tree for the string AAA BAB. Okay, LMD and RMD we have to draw, and parse tree is nothing but this is the same thing, parse tree. By seeing the derivations, we'll be making a tree that is called as parse tree. So we have to find out LMD and RMD for the given grammar, and the string is AAA BAB. Now the same thing again we'll do. We'll consider AAA and BAB here. See, in the previous one, what they had given is the string which they had given was a plus b star a minus b. Okay, both questions are actually same only. The only thing which they have given is a separate way. Okay, see this expression they have given here. This expression is given to us, and this is the rules they had given. Now this is the rules which we have been given. So it is both same only. Okay, all you have to do is keep the string in mind and proceed. Okay, now a b a b for LMD. I'll be starting with S. Always you have to start with S. S goes to ABB. ABB I have written here. Now I have to start with LMD, right? LMD means first I have to expand A. First I have to expand A means I have to see the first letter is A here. So instead of A, I have to get a small a. So I'll see the expansions of A. A can either become small a and capital A, or it can become epsilon. So this is the correct one. If I substitute small a and capital A in the A's place, in this place I'll substitute this one. So I'll be getting A here. Okay. Again left only I have to see first. Left is this one. What is my second symbol? Again it is A. So this A will become this again A. Now this A again it will become this A. After that I'll see I have all the A's done. Next my letter is B, and B is already present here. So I have no need for this one. So A I can substitute it as null so that A will vanish from here. After that I'll be considering the B. The next letter is B here. After that letter is A, and I have a capital letter B here. See, B is present here. I have to get answer AB. So from B I will check which will give me AB. From B I can use this one to get first A here, then again capital B, first A and again capital B. Okay, this will become this. Again A is here only, and this B again. A is done. Now I have a capital B here. That B, capital B should become this small b. So I'll check the capital B's transfer arrow here. So I'll be getting a small b and a b here, right? So instead of b I'll be writing small b and b. So instead of b I'll write small b and b. Again b will be remaining as such, and this b will be going to epsilon at the end. So this b will vanish from here. I got the string here. This one I did considering always the left and left. If I do it the same thing considering the right, I'll be getting the same answer here also, but from the right I'll be getting. Right means first I'll consider b. B means I have to get the final answer here as b. So if I have to get the final answer here as b, I have to first take a here, right? Because ab only I can get. I cannot get directly b here. What happens if I write just b here? If I write b and b here, this b will become null, and what I will be having is uh, a will be present here, and I mean sorry, what will happen is b will be present here, and this will become ABB. I'll get ABB, right? See, what I'm trying to say is ABB is given here. Cool. Now I have to start from the right. Now from the right, if you see this first letter, it is B. So B with B. If I use the same technique and write BB, what will happen? This will become BB, right? Obviously, and my string has been become wrong because two consecutive B's have come which are not present in this. So here you have to apply your common sense. Your common sense, what it will say? First, if I want here B, before that I have A here. Let's handle A and B first, then we will handle the remaining one through A. Okay, through A I can handle these ones. Okay, but these two has to be handled by B only. So if these two has to be handled, first A have to take into consideration. So B will be substituted as AB, and then this B will be substituted as BB. This B will be taken epsilon and it will be vanished, so that I will get AB after this particular B. Okay, this particular B was already present here. After that, I've got here as AB. Now using this A, I'll do the same thing again. I have A here. So A I'll substitute as AA, then this A I'll substitute as again as AA, this A I'll substitute as AA, and this A I'll substitute as null, so that I'll be getting this final string here. Okay. Now, after you have done this and this, you can take any of these and create a parse tree. I will create the parse tree for LMD. Usually it is easier. So what you have to do first is S, where it goes, A, B, B. So S goes to capital A, small b, and small b. Now capital A, what it became? Capital A became small a and capital A. So capital A became small a and capital A. Now next capital A became what? Next capital A also became small a and capital A. This also became small a and capital A. Next capital A, what it became? Small a and capital A. Next capital A, what it became? It became epsilon. After that, B remains same. This B, what this B became? This B became first as what is this B became? B became BB, right? BB it had become. Sorry, not BB, it had not become BB. This B is already present from the question itself. The thing is, this B was expanded to AB here, right? So I'll be writing here AB, and the second B expanded to BB. Okay, the second B is present here. This expanded to small b and capital B. So this B became small b and capital B, and this capital B became epsilon. The B remains same from the previous state, and this became epsilon. After you have done this much, you'll make these two arrows. This one arrow and this one arrow. Now what does these arrows indicate? These arrows indicate that the end letters is a epsilon will ignore, end letter is b, a. For each branch, what is the end letter, that we will combinedly write and we'll get the final same answer, which is present here and which they are asked in the question. Okay, that is about the making the LMD and RMD parse tree for the ambiguous and ambiguous grammars, and using the following type and the above one also. Okay, so mostly these two types, either of them will be asked in exam. Okay, the second type in the or which can come in the same or is the construction of CFG. You have to construct CFG for this one. They'll give you questions like this, and you have to construct the CFGs. We will be discussing 5 ones. This is from the 2024 model paper. Okay, this year only which model paper has released for the 22 scheme. From them, from that paper, this question is. Okay, so very important one. Here we'll understand how do you construct a CFG. Okay, context free grammar for the following languages. So languages given are 0 n and 0 power 2 n and 1 power m. Okay, so this is the language given. L is equal to null 001. See what the question they are given. Observe carefully. L is equal to 0 power 2n and 1 power m, and n's value and m's value can be greater than or equal to 0. So what is the least value of n? Least value of n is 0. Least value of m is also 0. Substitute 0 and 0 here. When you substitute 0 here and here also, the both of the terms will vanish. I'll be remaining with a null here. Okay, we have to take the least values and substitute and see what answers we are getting. Then least value for n. Least value for n 0 we have taken here. So least value for n the second time it will become 1. Okay, when n is 1, this will become 2 into 1. 2 into 1 is 2. So 0 power 2 is nothing but 0 0. Got my point? Now n is 0 only, m is equal to 1. When m is 1, this will become 1 power 1, which is 1 only. 1 time 1 repeated. Okay, now 1 1 is done. Now it will be 1, so it will become 2 1. Okay, we can take in any order. We just want some strings here. Okay, so I'll take n is equal to 2. Okay, first I'll take n is equal to 2 and m is equal to 1. Okay, if I take n is equal to 2, m is equal to 1, n is equal to 2 means this will become 2 to the 4. 4 zeros will be there. 4 zeros will be there, and m is equal to 1 means only a single one will be there. Okay, I can do it in that way also, or I can do it in n is equal to 1, m is equal to 2. If I do n is equal to 1, m is equal to 2, this will become double 0. M is equal to 2 means this will also become double 1, double 0, double 1. Like that, we need some alphabets here. Okay, after we have done this one, we will be starting to make this answer, final answer here. Now observe carefully how do we do this. Okay, observe carefully how do we do this. See, 0 is repeating 2 times and 1 is repeating single time. Okay, so we cannot have a comparison here because the numbers are also different. This is becoming double. Double means the number of zeros can be either 0 zeros or 2 zeros or 4 zeros or 6 zeros and so on. Always it will be even number, right? It will always be increasing in 2 times. Firstly, nothing will be there. If n is equal to 1, 2 zeros will come. If n is 2, it will become 4 and so on. So 0, 2, 4, 6, like that it is growing. So what you have to do is first write s is equal to s goes to, write two things here, a and b. Okay, because there is no correlation between 0 power 2n and 1 power 2m. Variable is also different. If variable was same, we need to think that should we take 2 or 1 will be sufficient. Okay, but in this case there are two different things. Different thing means it should be handled differentially, because of n value this can increase as many times, and m value also it can increase as many times. It is independent, there is no dependency, so we have to handle it separately only. This is for 0 power 2n and this is for 1 power m. We'll handle it. Okay, after that it can also be epsilon. Why? Because if both the values are 0, it will be empty string, so it will be satisfying this particular string. S goes to epsilon. Now a and b, how we'll handle. A goes to 0 0 s. Why 0 0 s? Because whenever we take a as 1, suppose that we take n value as 1, so when n is 1, 0 0 will come. Okay, after that again I can have n number of zeros, or I can start with the m. Okay, to again I have options. Again I have options means again I can come to this state and take a or b again from here. So the same thing I'll be writing here, 0 0 s again. Okay, after this I cannot write a here. Okay, you can also that question might come, I can write a also here. But if I write a here, what will happen? A goes to 0 0 a, it will stay in the same state only and I'll never reach b again. So in order to reach b again after a has been over, I have to write s here, so that after all these a's are over, b can also start. Okay, now you can think that I can write it as ab also here. I can write it as ab also, but that will be the same thing. S goes to AB. Instead of AB, I'll write directly S. Right? That is more simplified one. Okay. So like that, you can decide what you want to do. Okay. All are correct answers only. Now, after I've written this S here, again S can be A or B again. If again I'll take it as A, and again two zeros will come here. 0 0 because of A, and B will be here. And 0 0 s and then b will be here. Again s I can take it as a, or I can take it as epsilon, then b will be starting. Okay, so you got the point, right? A is for double zeros, and after that I can have another a's or b's, or means zeros or ones I can have. So I put here s, and a can also go to epsilon. Why? Because uh, I have to finish start I have to finish a before I can go to b, right? If I don't put epsilon here, what will happen? S goes to A goes to S, S goes to A goes to S, B will never come. So when I want to denote that it is over, okay, A's input is over, zeros are over, I'll put the final A as epsilon, so that A will be epsilon here and then B will be starting. Now B is simple, B is only 1 here, 1 power m. So whenever single 1 is there, so I'll get 1 and again B will be here. If I want to repeat, m is equal to 2, again I'll take 1b. Single it will increase because it is 1 power m, but here double it will increase because it is for n is equal to 1, 2 time it will increase. For n is equal to 2, 4 time it will increase. So that's why double zeros here. Okay, and also b has to end, so it will be epsilon here. What's the point? Like this you have to write here. Firstly, write the language here, what are the symbols here, and see the symbols and observe whether they are correlated or not. If they are not correlated, separate it. If they are correlated, put it as same. That question also will be discussing whether in case they are correlated, how do you do that. Next question is the correlated one only. Okay, and based on that you have to see how much it is increasing, 2 times, 4 times. The key is practice. Okay, practice as many questions as you can. Watch my module 3 video of TOC. The link you can find in the description box, the playlist link. There I have solved few questions. Okay, you can refer to that and learn from there. Okay, so this is the answer for the first question. Moving on to the second question, where we have been given L is equal to WWR and W belongs to AB. So strings of A's and B's are there, and W can be 0 also. Okay, so what is WWR? WWR means whatever the string W is there. For example, string W is ABB. WR means reverse of ABB. What is reverse of ABB? BBA. So the final string will be ABB BBA. For this, we have to define the grammar. So what is the least string we can form? Least thing we can form is null, because the star is given here in the question. Star is given in the question means A and B can be repeated 0 number of times. So if it is 0 means W will be 0, WR will also be 0. That means it's a null string. Null string is accepted, so we'll have to have S goes to null. Okay. The first thing we'll write here and leave some space here. Next, what is the least string I can form? If I take W as only A, W as only A, then WR will also become A only. Reverse of A is A only. If I take B, the reverse of B is B only. If I take AB, reverse of AB is BA, reverse of BA is AB. Okay, so these are the strings which will form. So like that we'll be writing here. After that, how you will be solving this question? If you observe carefully, whatever the letter I'm taking, that letter is in the ending also, right? This is what is a palindrome, right? A. Whatever I am taking, that is in the ending also, and in between we have to fill other values. So if I write S goes to A S A and B S B, I'll be able to get the palindrome here. Why? Because see, A goes to A S A. Okay, so, let me explain it here. See, this is very simple question. Okay, understand what's happening here. Okay, see, A goes to ASA. Let's take an example string of ABBA, or let's take a bigger one only. Okay, ABA ABA. Okay, now see, I'll take S goes to ASA. Now this S can be substituted as, again, A is there, next is B, right? I'll put it as BSB. Okay, this one I'm taking BSB instead of this S. This will be substituted as BSB, so I'll take BSB here. Now again this S can be substituted as A here, so ASA, and after that the final S can be substituted as null, so this will become null here. Okay, so this will vanish out from here. Now if you read the string ABA, I had substituted is in this way, right? A and this vanished, so it will be A, and after A it was this. See, it is in between. I am writing between B and B, I am writing AA, so this is BAAB, and this whole thing is written in between double A, so ABAABA. Okay, ABAABA. Whatever I'm writing here should be repeated at the end here in that same order. Second last will be second last here, third will be third last here, and so on. You got the point? This is how the palindrome is. Okay, so this is the grammar for the given palindrome. Got the point? Okay, this is also in the case where it is related, because what A I am taking first here, that A only should be coming at the last here, so this is related. So whenever it is related, we'll not take two states as we took here. When it's related, we'll take the same state here, S only. Got the point? Okay, the key is, again, practice as many questions, you'll get to know how these things work. Okay, W. The third question given is W belongs to 0 and 1. So zeros and ones are there in the string with at least one occurrence of 101. So 101 is compulsory. Least string will be 101, very simple. And after or before 101, we can have n number of ones and zeros. Got it. So very simple. S goes to 101, and here an A, here an A. And A can be either 0 or 1 and can be repeated n number of times. So again it will be going to A, so that if I want another 0 or 1, I can take from this A, and again A will be there. Again, if I want to continue, if I don't want to continue, I can put it in an epsilon. So S goes to 101, here an A, here an A goes to 0A or 1A or epsilon. Got the point? Okay. Now the next question is L is equal to strings of A's and B's with equal number of A's and B's. So A's and B's, the number of A's and B's are equal. Okay, you got the point. The number of A's and B's are equal. Here also it is correlated, because the number of A's are there, that should be equal to number of B's. We can't take it separately. If I take it separately, I'll take it 100 A's here, B will not know what's happening. Okay, so here it's very simple. Again, what we'll do, whenever I'll take an A, okay, what is the least string? 0, because if 0 is there, the 0 number of A's is equal to 0 number of B's. That is valid. 1A, it should have a B also. 2 A's I take, 2 B's it will come here. Order does not matter. I can take 2 B's here and 2 A's here. Okay, so number should be same. So to ensure that the number is same, what we can do is, whenever we take a particular alphabet, the corresponding alphabet of it should come at the end. Okay, at the end it should come, but it doesn't matter. See, I can make, by using these two rules, I can create any string. Okay, let's take BABA as example. Okay, BABA, how I'll form? Firstly, I'll use BA. Okay, see, BA, it is there. Now S again came. S, I can take it as AB. So by using these two combination, we can form in any order. Okay, so whenever A comes, B should come at the end, and S should be again substituted here for furthermore string. And whenever B comes, I can take it as A should be also there corresponding A, and s should be here. And whenever I want to end, I can take it as epsilon. Starting also I can take it as epsilon. So that we'll be getting this string. If you use these two combinations and then use epsilon, the rest all the string will be taken into consideration. Got the point? So this is about strings of A's and B's with equal number of A's and B's. Again, observe here, since it's related, we did not take any other letter. Only S only we used. Okay. Now the last one, language of strings of zeros and ones having substring 000. Very simple. What's the minimum string? 000, and we don't care anything else. 000 is present here. Before that, after that, n number of zeros and ones. So 000 here, n number of zeros and ones can come. A can be defined as 0a, 1a, or epsilon. Okay. This is about the CFG. How do we define a CFG? Okay, so don't miss in module 3 how to define CFG. Practice as many questions as you can. CFG is important. Okay, CFG is important. And before that, we had discussed the LMD, RMD, and ambiguous trees, parse trees. Okay, these four things you need to discuss. Solve as many questions as you can. Okay, moving on to the fourth module. Okay, in fourth module, what we have? Okay, so in fourth module, mainly we have the CFG to CNF. This is only the main topic you need to know. Okay, apart from this, forget everything. Only you need to know the process of converting CFG to CNF. If this only you know, you can easily score 80% marks in the module 4. Okay, see. So while converting CFG to CNF, there are some rules to be followed. Okay, that rules I have explained in the module 4 video of my TOC, that you can find in the link in the description box. You can find there with ample examples. You can easily get to know what are the steps to be followed. Okay, here I will be going a bit fast, but still I will be explaining the rules also. But if you want more information, watch that video. Okay, there I have explained very clearly how do you solve any type of CFG to CNF questions. Okay, 4 steps are there. So see here. So a question can come like this: remove all the epsilon productions and the unit productions from the grammar. Another can come as useless production also. Okay, this is also a part of the rule. They can ask this also, useless question. So for this question, I'll be solving epsilon production, unit production, as well as useless also. I'll be giving you a hint how do you solve it. Okay, so that if useless also come, you can solve that one also. Okay, so let's start with this question. Okay, the first rule. Okay, what is the first rule? First rule is that what are the grammar they had given, right? What is the grammar they have given? That grammar you have to write it again here. Okay, and leave some space and write. Okay, because changes are to be made. S goes to capital A and A B B. Okay, and capital A goes to A, and epsilon. B goes to B B, and B B C. C goes to C B. I mean C goes to B only. Okay, is it correct, right? A B B, A epsilon, B B B B C B. Okay, done. This is also from the model paper 2024. Okay, for the 22 scheme. Now S goes to A. Now what you have to do? First, they have asked is remove the epsilon production. Now, what is an epsilon production? In this whole equation, can you find epsilon? Can you find epsilon? Is epsilon present in here? No. Is epsilon present here? Yes, it is present here. Is it present here? No. Is it present here? No. Whenever epsilon is present here, we have to remove it. What do you mean by removing? For removing, we'll be writing here epsilon is nothing but null production. Okay. So in order not to confuse you, let's write epsilon production only. So epsilon production, which letter is forming epsilon production? A. So I'll be writing here A. Is any other letter forming? No, it's not forming. So I'll keep it as A only here. Okay. Now, next thing what you have to do is you have to observe from A, epsilon has come, right? So wherever in this whole equation, wherever you find A, put epsilon one by one. Okay. Now, and epsilon you remove from here. Okay. Put epsilon one by one wherever you find A. Now start from here. Here where you can find capital A. Capital A can be found here. If I put epsilon in this capital A, this will vanish from here. So the remaining one will be only A. I'll be writing only A here. Is capital A present here? No. Is capital A present here? No. That. Now capital A goes to this, two capital A are there, so I'll do it one by one. If I put epsilon in one of them, it will be A. If I put on both of them, my answer will be A. Is any other A here? No. Is any other A here? No. And any other letter is there? No. Only A was there. So this is the answer for the first one, epsilon production. Okay, epsilon production removed. Done. Epsilon production is removed. Now we have to remove the unit production. Okay, now I'll just copy paste it here. Okay, Okay, I'll just copy paste it here for unit production. Okay, insert some space here. Okay, okay, see here. To remove the unit production, what is a unit production? Unit production is capital to capital. Okay, capital to capital. Okay, that is what is called unit production. Now, to remove the unit production, what you have to do is, okay, unit product. Observe which are having the unit productions. Okay, so which unit productions are present here? In this equation, which unit productions are present? Can you identify and tell me unit productions which are present? Capital to capital. Capital to capital, this is there. Is this unit production? No, it has a small letter also. Terminal is there. Small letter is called as terminal. Capital letter is called as non-terminal. Only single should be there. Then only it will be capital to capital. It is there? No. It is there? No. It is there? Yes. This is capital to capital. I'll write the production here, C to B. This is the unit production. How do we remove the unit production? Very simple. What you have to do is to remove the unit production, C to B is the unit production, right? So B, instead of B, I'll be writing this thing. Okay, I'll cut this B and I'll write this thing here. B, 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 C. Okay, that's it. This is the removal of unit production. That's it. This is the final answer. Okay. Unit production removed. Got my point. Now there is no more unit production present here, so therefore the unit productions are removed. Okay, BB, BB, C. Okay, that's all about the unit production removed. After this, you have to remove the null productions. In case they ask, sorry, not null, useless production. In case they ask you about the remove the useless production also, we'll have to do that also. Okay, so I'll be telling you how do you do. In case they ask for the same question, remove useless production also. Okay, for useless production, this is just for example. Okay, it's not asked in the question paper. Okay, in case they ask, because they also ask the useless production also, I just took an example of unit and epsilon. Okay, so in this case, what we need to do to remove the useless production, I'll first take the same thing here again. Okay, okay, so these three rules are there, and these three rules also you have to follow in all of the CFG to CNF type of problem. Okay, in all CFG to CNF type of problem, you have to follow these three rules first and then only proceed. Okay, without this, if you proceed, you'll get the wrong answer. Now, what is useless production? Useless productions are the one which useful productions are not there. Okay, what is useless? Which is not useful. Okay, so what is useful we'll write first, and whatever is not useful, automatically it will be useless. Now, see here, useful, all the terminals are useful, small letters. Which all small letters we can see? B is there, A is there, all the small letters are useful. And which letter defines these two, those are also useful. S defines A, right? So S is useful. A defines A is also useful. Okay, B defines, no, only single it should be there. Okay, if double is there, it is not considered. Single A or single B, if it is there, then only it will be considered. Now for B there is nothing. C, there is nothing here. What we have, if there is nothing, means what we have? B and capital B I have. We'll check each of these. Is the small b present here? Yes. Capital B is present here? No. If both of them are present here, I'll be taking this into consideration and taking this as useful. But even if one of them is not there, I'll be taking it as useless. Okay. Before that, I'll check this also. B is there? Yes. B is there? Yes. C is there? C is not there? This is useless production. Okay. If both of them do not qualify for the useful production, I'll be marking the letter which generated that as useless. Okay. Then coming to C, BB, it's not there. BBC, BBC is also not there. Again, C is also useless. Now we have considered B and C as useless. Now, after we have considered B and C as useless, you have to also see which are deriving B and C. That also will be marking it as useless only. Okay. Now B and C are useless, so we will be just removing it from here. Okay. For your information purpose, I'll keep it here only. I'll not remove. But you get the point, right? Now B is useless means wherever you find B, those all become useless. Okay, this became useless, this also became useless, so we'll remove it. And since A and A two times it is there, we'll just keep it as A, and A also does not have B or C here, so that's it. So in final answer you'll remove this one. Okay, you'll remove this one and only this one will be the final answer. You got the point. And one more thing you have to check is S goes to AA and capital A goes to these things. Now if it was like this, S goes to capital A was not there. Okay, if it was just S goes to capital A, S goes to small a, if it was like this, then I cannot reach A by any chance. I'll start from here, I'll go to A, that's it, end. So this will also become useless because there is no way I can reach A from S. S is a starting set, I cannot reach to A, so that will also become useless. So in that case I would have written it, but since capital A is there, this is useful only. Okay, so removal of useless protection, final answer is this one. Okay, in case they asked in the exam. Okay, after this rules you after the rules we have to start with the CFG to CNF. Okay, see, two back to back two questions, same topic. Obtain the following grammar in CNF, define CNF, convert the following grammar to CNF. Both of them you have to convert into CNF back to back. 6 plus 8, 14 marks. One topic you learn, 14 marks you'll get from here. And this question, wow, how many marks are there? 6. 14 plus 6, 20 marks. Full on full you can get by just knowing this one concept, CFG to CNF. What's the point? How important and repeated it is. Also on top of that, it's so much repeated. Also in the model paper, it's come. This is from the model 2024 paper. Okay, latest model paper of 22 scheme. Okay, so let's understand how do you solve this question. Okay, the first question we'll be writing here. The first step. Okay, we leave some space at the top. Write it A, S, B, and epsilon. Then A goes to A, S, and small a. Then B goes to S, B, S, A, and BB. Okay, this is the thing which is going to just confirm much. ASB, epsilon, AAS, and A, SBS, capital A, BB. Done. Now we'll solve it one by one. Okay, so the first rule. Okay, the first rule, how to convert CFG to CNF. If you want the actual detailed explanation for this, if you don't understand anything here, watch the module 4 video of my TOC video. In that I've explained it with plenty examples along with the steps also. Okay, so here I'll be moving at a bit fast. The first rule is, if the starting symbol is appearing in the starting symbol here only, then we have to take a new starting symbol. That's the rule. Okay, starting symbol appearing here only, we have to take a new starting symbol. S dash goes to S, like this. Now starting symbol is this one. Got the point? Okay, this is the first rule. Okay, after this what you have to do, okay, this is the first one. After this what you have to do, the second rule is remove the null productions. Okay, second rule is remove the null production. This is the null production, which is from where it is coming, from S it is coming. So wherever you find S, put as null. Wherever you find S, put as null. Start from here. Here if I put as null, okay, done. There is null here. Next, S here is S, if I put as null, this will be AB. Here if I put as null, I'll be getting as AA. Here if I put as null, I'll get two answers. First null if I put, you'll get as BS. If I put as second as null, I'll get as SB. If I put both as null, I'll get as B. The removal of null production is done here. Okay, the starting symbol can have null. Okay, starting symbol can have null, other should not have null. Okay, that's the rule. Third rule. Third rule is remove the unit production. How do we remove the unit production? Unit means capital to capital. Can you see any capital to capital in this whole thing? Starting set, leave that starting set. And other than starting set, any other have capital to capital? Yes, this has capital to capital, right? So we'll be removing this one. How do we remove the capital to capital? We'll just substitute this whole thing in the place of A. Okay, got the point. The whole thing will be substituted in the place of A. So I'll be doing it in a different way. What I'll be doing is, first this A is there, right? I'll be writing it here, A, and remaining two I'll be writing at the end. It's the same thing only. AS and AA. Now, removal of unit production is also done. Third is removal of useless production. What is useless production? That which is not useful. Which is useful? Useful are the small letters. Small letters are A and B. So A and B are small letters. Who is deriving A and B? A is deriving A, B is also deriving A and B also. So A and B are useful. Now we'll start from here. Leave the starting state here. S, A, S, B. A, S, B. A is present here. B is present here. S is present here. No. Consider the next one. A, B. A, B both are present. So if A, B both are present here, this is useful. This is useful means S also becomes useful. So S also becomes useful. Now since S has become useful, from this S dash also become useful. So since S dash also become useful, we have all the symbols present here, all are useful. So there are no useless symbols present in this question. Okay, so useful. Now after you have followed these three rules, we are ready to convert this question into CNF. Okay, after this you have to convert it into CNF. Okay, so I'll just copy paste it here and solve this. Okay, done. If you have not liked and subscribed to my channel, please do like and subscribe. It helps me make more videos like this. Okay, so let's continue. Okay, see, this is before the rules. Okay, um, how do I write this? Applying rules. Applying rules of um, null, unit, and useless productions. Okay, so these are the rules which are applied here. Cool. After the rules are applied, ready for CFG to CNF. Now see, for CFG to CNF, the simple rule is present here. All the what is this called? This is called as I'll call it as arrow. All the arrows or the I'm forgetting that word. Okay, I don't know. I'm not remembering what is this called. Okay, all the arrows or the equations which are given here, those should be of the form S goes to S is just for representational purpose. Either it should go to a single terminal or it should go to two non-terminals. Okay, these are the only two rules. Okay, all of them should be of this form. Okay, rules. This is the rule. Either this or this, if it is there, that is valid. Okay, now see, S dash goes to S. Is this valid? No, it's not valid. Why? Because S dash goes to S here, but here we don't have that kind of rule here. Okay, so we'll be solving it one by one. Okay, first step is take A here. Okay, A is going to single A here. That A will be wherever we have here, that will be converting. Okay, so let's start from here. Okay, starting state you will be taking it later. First we'll start from here. Okay, here the first A S B, is it in the state which we are trying to see? Two non-terminal? No, this is having three non-terminal. This is fine, but this is having three non-terminal. So what we need to do is we need to find another state. Suppose that we'll take the state as let's take TU. Let's take U. Okay, you can take any letter. Okay, U goes to AS. I'll be writing. Okay, U goes to AS. I'll be writing, and then instead of AS, I'll be writing it as U. Now see what happened. S goes to UB and AB. Right, S goes to UB and AB. It's of the form this one. Single non-terminal goes to two non-terminal, and single non-terminal goes to two non-terminal. Okay, so this become a valid one. This is also valid one. Here I have three. Okay, I have three, but here are non-terminals also. I mean the terminal is also present here. For this, what we need to do, if we do it in the same way, suppose that V goes to A, and I'll proceed again. So again here it will become a problem. Why? Because again V goes to A. This is neither of this form. So in these cases, what we do is we'll be assigning a letter which is going to a single terminal. Okay, V goes to A, like that we'll be writing. So wherever we find small a along with non-terminal, listen to me carefully. Wherever we find small a along with non-terminals, we'll have to replace it with the non-terminal. Okay, this a will remain as same because it is valid. A goes to small a goes to small a, this is valid one. But wherever it is along with a non-terminal, we'll have to replace it with this non-terminal so that it becomes a valid one. Okay, now again for the B also the same thing we will be doing. Before that we also need to have a VA separated, right? So we'll be separating VA also, but we'll come to that later. Okay, so B goes to SBS. So B will be I mean UVW, will take W for B, and wherever B is there we'll substitute it as W. Okay, BB is it fine? BB is also not fine because two non-terminals should not be there. So WW it will become. Okay, and BS is also not fine, which should become W. SB is also becoming W. Single B is fine. A should become as capital V, and this A also should become as capital V. Now, after that, which are remaining, which are still not satisfied. VAS is not satisfied. SWS and VAS. So VA I can take it as separate. Okay. UVWX. I'll take X as VA. Okay. So instead of this, I can substitute it as X, and this VA is already fine. I'll not replace it. Okay. If I substitute this also as X, what will happen? See, this is becoming a wrong one. A goes to X. It is neither of this form. So that's why you should not touch the ones which are already fine. Okay. So here also VA, this will become X. Okay. And then SW is there, right? So we'll take X Y as SW. Okay. Y as SW. So this will become Y. Okay. Now I think all of them are in proper form. Just the first one is not in the proper form, but this is fine. Okay, because this is a starting state, that will be remaining like that only. Okay, that's not an issue. Okay, so yeah, I think this is pretty much it, the final answer. Okay, this whole thing is the final answer, and you can get different final answers also. Okay, based on the letters you choose and the way you define. For example, if instead of AS I had taken SA as U, I would have got somewhere else as U and B. So the thing is, it should satisfy the condition, these two rules. Till you satisfy the condition, the answer is valid one. Okay, got the point. Okay, so this was about the first one. Convert the following grammar into CNF. Okay, second question also is the same one, same rules you have to follow, and we have to do. Okay, so I'll be discussing the second one as well. Try the second one by your own. Else you can watch this explanation also, video also. Okay, so let's write the question. Define CNF. Okay, so the definition of CNF I have not given here. I think you can find out from the notes only, the official notes. Okay, define CNF. Find in the official VTU notes. Okay, because definition if you don't write, you'll get, means some marks will get cut. Okay, official VTU notes. Okay. Okay, you can easily find that and learn from there. It's a simple definition only. Okay, it will just define what is non-terminal, what is terminal, and this transformation is there, that equation, that word is there, that also will be there. Okay, don't forget, define CNF, find in the official notes. I'll be focusing into S goes to 0A and 1B. Okay, S goes to 0A and 1B. Okay, after that, what is there? A goes to 0AA, 1S and 1. 0AA, 1S and 1. That is A, right? A goes to, okay, 0A, 1S and 1. 1BB, 0S0. 1BB, 0S0. Okay, this is not OS, this is 0S, and from here B. Okay, let's confirm first. 0A, 1B, 0A, 1B, 0A, 1S1, 0A, 1S1, BB, 0S0, BB, 0S0, 1BB. Okay, 1BB, 0S0. Okay, done. Now, this is the thing which is given to us. Here we need to check if it is having the first rule. What is the first rule? Starting symbol is appearing here. No, it's not. So, we are good to go. We will not take any other starting symbol. Next. After that, the second rule is epsilon null production. Is there any null production? No. Is there any unit production? Unit production is there? No. Is there any useless production? Useless means which are not useful. So what is useful? Useful is the terminals. What is terminals? Is 1 and 0. 1 and 0 is terminal. From where 1 and 0 came? A, B. A and B both are useful. If A and B both are useful, 1 and 0 is also useful, S is also useful. So all are useful, there are no useless production. You can directly proceed with the question. Now, the rule. Which is, what is the rule? The rule is S goes to A, it should be in this form, or S goes to AB. Either two non-terminal or one terminal. Okay, one terminal or two non-terminal. Here, in this is in the proper form, this is also in the proper form, this is not in the proper form, this is also not in the proper form. Actually, this and this is also not in the proper form because this is a terminal. Okay, I forgot. Okay, so we'll be first defining X for 0 and Y for 1. Okay, after we define X and Y, we substitute whichever places 0 and 1 is there with X and Y. The only places where it is with the non-terminal, not alone. Okay, this one will not replace. This one will become X here, and this will become Y here, and this will become Y here, and this will become X here. Okay, now which is still not satisfying the rule. satisfy. These two are not satisfying. Okay, so we'll be making a change to this one. We'll take another letter as W, or we'll take it as V. V goes to XA and W goes to YB. Okay, XA and YB will substitute it as VA, and YB can substitute as Y. Okay. Um, what was present here previously? YB, right? YB you have to substitute as W. Sorry. Okay, W. Now it is in the form of CNF. Okay, this is the same thing, same rules you have to follow. And for more detail, if you want more examples of this same concept, please watch the module 4 video of TOC, which I have uploaded. You can find the link in the description box. And don't miss this question, CFD to CNF. This one question can make you score 20 marks, means full marks also you can score, and most probably you can score more than 80% marks in the module 4. Okay, let's move on to the module 5. The first question is a theory question, very important and repeated one. You just have to remember a few key concepts. Define Turing machine, explain the working of Turing machine. So what is a Turing machine? A Turing machine M is a 7 tuple, namely Q, sigma, and this slide I don't know what it is, delta, Q naught, B, and F. Okay, now see Q. Okay, Q is the finite set of states, all the states. Okay, Q naught, Q1, Q2, all the set comes here. Okay, and this symbol, a finite non-empty set of tape. Okay, tape it is. Tape also I'll discuss what it is. B is blank symbol. Okay, sigma is non-empty set of input symbol. What are the inputs can come? A, B, C, D, and all. Delta is a transition function. Q naught is the initial state. F is the final state. Okay, these things you have to just write the definition for Turing machine. After that, working of Turing machine. The Turing machine can be thought of as a finite controlled connected read-write head. Okay, there will be a read-write head which will be connected and it will be moving. It has one tape which is divided into many cells. There are many cells divided and it is a single tape. Okay, so the block diagram of the basic model is given below. Okay, so here you have to make it like this, a tape here, and here we will be writing the symbols A1, A2, A3, and followed by a blanks here, B, 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 and so on. Read write head is here and finite control is here. Okay, each cell can store only one symbol. Okay, each cell can have only one symbol. The input and the output to the finite state is offered affected by RW head. This RW head, the input will be written by this and the output will also be taken by this only at one cell at a time. It simultaneously can determine four things: new symbol to be written, motion of the tape, whether it is left or right. So this tape can move either left or right. Okay, based on the scenario. Next state means in which next state it will go, and whether to halt or not means whether it has reached the end, whether it should stop moving or not. Okay, these four things will be determined: new symbol to be written, motion of the tape, next state, and halt or not, simultaneously by the RW head. Okay, this is how the Turing machine works. Let's attempt a question which is related to the Turing machine. This is a very important question. A lot of papers have the same question. Another one is there, 1 power n and 2 power n also. Okay, or a power n and b power n, like that. Those also corresponding to this type of question only. Okay, but here we have 3 also, so it will be a bit different. Okay, if you want the solutions for the other ones also which can be asked, please watch the module 5 video of TOC which I have uploaded. They have solved I think 8 questions. Okay, which are the most repeated ones, and beyond the eight questions, no questions will be means coming in the exam. These are the 8 questions only from which the questions can come from Turing machine. Okay, so if you want you can watch that also, but this is the most repeated one. Okay, first watch this one. Now see, also if you understand the concept, can easily solve. Okay, so along with this theory, this definition, I mean that this Turing machine, one question you need to know it very well. After that also one theory, important, super important question is there. We will discuss that. Okay, so see here, design a TM for the language. This language is given showing that the string 112233 is accepted by the ID, instantaneous descriptor. Okay, first you have to make the Turing machine. How you will make the Turing machine? In Turing machine, first you have to make a state here Q naught. Okay, now in the Q naught, uh, first my string. Okay, my string is what, 112233. Okay, this is a string which is given to us, so we'll take this same string into consideration and we'll proceed. Okay, now see, I am at Q naught. Okay, and my read write head is present here. Okay, now what I'm encountering, I'm encountering 1. Whenever I encounter 1, my rule is that I'll make that 1 as x. Okay, I'll make this 1 as x, and what I will do, I'll move to the right. Like this you have to write what you encountered, what you will make it as, and where you will go. Right, so right means I'll be going it here. Okay, after that I'll reach Q1. Okay, in Q1 I found another one here. No matter how many ones I find here, I'll be staying in the same state and I'll be If I find 1, I'll be keeping it as 1 only and moving to the right. This is the rule. Okay, whenever we find the first symbol, after that the same symbols, how many times it's repeated, it will not matter, we have to keep moving forward. And while how many ones are there, suppose that 3 ones were there, it will skip all 3 ones and it will reach here. Whenever I reach 2, whenever I encounter 2, okay, suppose I encounter 2, I'll make 2 as y. Okay, for different symbols we have to use different letters, and I'll move again to the right. Okay, I'll move to the right again. After moving to the right, no matter how many 2's are there, I have to skip all those 2's. So I'll be making another self loop here, which will be 2 comma 2 comma r. Okay, I'll be skipping all the 2's here. Okay, I'll insert some space here, it's becoming too much congested. Okay, and okay, 2 to r is present here, right? So 2 to r, I'll make it here. Okay, 2 comma 2 comma r. Now I have moved to the right. Now after that, I'll find a number of 2's and I'll skip all of them. I'll move to the 3, and this 2 I had made it as y, right? I forgot to change this 2. I have made it as y, right? This 2 I have made it as y. Now I'll move to 3. Now when I am in 3, okay, if I encounter 3, I'll make it as z and move to the left. I'll not move to the right. Okay, I'll move to the left. You got the point? I'll move to the left. There is a reason for that. Okay, I'll be explaining why I'm moving to the left. Okay, okay, I'll be moving to the left from here after marking it as z. Okay, don't confuse, this is 2. Okay, this is 2, I'll write 2 like this. Now when I move to the left, I'll be encountering n number of 2's. Okay, I'll be moving to this state q3, and in q3, when I move to the left, I'll be encountering n number of 2's here. So all those 2's I have to ignore. Okay, because I'm going back and finding the next one here. Okay, so that's why how many 2's I get, I'll have to ignore. So 2 comma 2 comma move left. After the 2's is over, I'll be finding y's here. For all those y's, I have to ignore y comma l. After ignoring the y's, I'll come 1 here. Once also I'll ignore 1 comma l. I need the first one. Okay, so I need to find out which is the first one. Then I'll reach x. Whenever I reach x, that will denote that I have reached the end. Okay, so whenever I reach x means that is the one after which the first one is there. So whenever I reach x, I'll be coming back here and I'll be writing x comma r. X, I'll keep x as same only and move to the right. So now I'm currently present at the first one. So basically what happened here, the thing is 1 power n, 2 power n, and 3 power n. How many ones are there? That many 2 should be there, that many 3 should be there. And this is a string which is given. So why, by doing this the thing in this way, what's happening for this one, this y is marked, this 2 is marked, and this 3 is marked. So for one set, 1 2 and 3 is marked, another set 1 2 3 is marked. That will ensure that the number of 1's 2's and 3's are same. That's why we are using in this way. Okay, that's why you got to know after z why we did not go forward, because we need to check which another set is there which can be taken and again move forward. Okay, until this is over, we need to move forward. How many ones are there? That many 2 should be there, that many 3 should be there. That should be confirmed first, then only we'll reach the final state. Okay, so now we are present at 1 and in this state. Now what is the rule? 1 comma xr. So I'll be just making it as x and moving to the right. So when I move to the right, I have y here. Okay, now when I move to the right, I encountered a y, but the definition is not present here. Encountering 1 is there, encountering 2 is there, but encountering y is not present. If I encounter y, just skip it, ignore and skip YYR. Okay, just ignore all the y's, and when I move to the 2, I'll be marking it as y and moving to the right. Okay, I'll mark it as y and move to the right. After I move to the right, I am in this state here. Now in this state, I am in right. I have to ignore n number of z's also, because these z's are over. I have to ignore n number of z's. So ZZR. Okay, n number of z's will be ignored, and I'll be moving to the 3. Okay, actually this is 2. Okay, not z. This is 2 I have written. Okay, don't get confused. 2 2 r, and we have defined for ZZR also. Okay, so the number of z's will be ignored and 3 will be here. 3 comma ZL, again 3 will be here, and 3 will become z, and I'll move to the left. Okay, now after I move to the left, I'll ignore all the number of uh, z's here and y's here and x here. Okay, also this is defined for 2, I'll have defined for z. How many z's are there? All I will ignore until I reach x. After I reach x, I'll move to the right. Okay, see, I'll come here and I'll reach x. While I'm considering x, because after x only the next one is there. In case the next one is there, I have to reach x. From there I'll check the next one and move here, like how we did in the previous iteration. So I'll reach till x. After I reach x, I'll keep it as x only and move to the right. When I move to the right, I am in this state. in this state, if I have 1, I'll again follow the same path. If I don't have 1 and I found as y, that means the number of 1s are over, the number of 2s are also equivalent, and number of 3s are also equivalent. How many 1s were there, that many y's are there, that many z's are z is there. Okay, so if I get y after an x, if I get a y, that means no more 1s are there, I have to stop executing. So after this, if I encounter a y, okay, I'll keep y as same and move to the right. Okay, I'll be moving here. Okay, I'll be moving here, and I'll be making a new state here, q4, and here I'll be ignoring n number of y's after that. Okay, y comma y r, I'll be ignoring n number of y's after that, and after that I'll be encountering z's also, so that also I'll be taking a new state here. Okay, z comma z, if a new symbol comes, take a new state, it is better. Okay, and I'll be ignoring the n number of z's after that, z comma r, and after all the final state here, there will be a blank space. Okay, there will be n number of blank spaces here. Okay, that will be marking the end of the string. After that, if I find a b here, okay, b comma b comma, you can keep it l or r, I'll be reaching the final state, which is q6. Okay, so this is how you define the Turing machine for the given language. Okay, now for this string we have to use it by the id. Okay, this is a 12-mark question, very important one, don't miss any of these things. After you have done this one, okay, you have to also write the transition functions. Okay, one transition function I will write, the rest of the thing you have to write by your own. Okay, now see, q naught is present here. Okay, q naught, when I am present in 1 and I have encountered x. Okay, when I am present in 1 and I have encountered x, what I'll be doing is I'll be moving to the right and going to q1. Okay, so here I'll be writing q1 comma r. Okay, like this, q1, and where I moved to the right. Like that you have to do for all of them. Okay, this is the transition function. Just confirm this syntax as same if it is having some different kind of syntax, but mostly this is the syntax only if I am writing it correctly, but just confirm it in the official notes also. Okay, so this is the transition function you need to write. Okay, like that for all of them you write a transition function. After that, if they ask you about the id specifically, you have to write. Okay, in most cases they'll ask it because it's for the 12 marks. So how do you do it by id? Okay, for the id also I'll start it and show the first few steps, because id instantaneous descriptor, it will take a lot of time. Okay, once you get the point, you will be able to do it by yourself. I'll be just showing you how do you start it. Okay, instantaneous descriptor. Okay, okay, now see, instantaneous descriptor, how you will do, just take the same string here. Okay, the same string is 112233, and the starting state you will take q naught. Okay, so write it like this. Okay, this symbol you make, write q naught 112233. After this, what you will do is you'll be writing this same like this only, q1 q naught on 1. Okay, q naught on 1, where it goes, q naught on 1, it goes to q1 and it becomes x. This one became x and went to q1 in the right direction. So what you have to do is q naught, it became it made it as x. Okay, it made this one as x, and q naught became q1 and it moved to the right. Got the point? It became q1, moved to the right and made it as x. Next, q1 on 1. After that, q1 on 1, you have to see this and see what will happen. q1 on 1, keep it as 1 only and move to the right. Okay, keep it as 1 only and move to the right. X, keep it as 1 only and move to the right, and stay in the same state only, 2233. Okay, again, q1 on 2. q1 on 2, where it's going? q1 on 2, it will make it as y and move to the right to q2. Okay, so this will be x1, q1 on 2, it will make it as q2, it will become q2, and first it will make it as y and it will become q2 and move to the right. Okay, very carefully you have to do. If any mistake is there, you might lose the marks. Okay, like that, after that, q2 on 2, like that you have to keep on going. If it is left, means the same thing, you do it in left direction also. Okay, for the more information of the entire descriptor, you can watch the module 5 video. There I have explained in the first or second question the instantaneous descriptor. The link you can find in the playlist in the description box. Okay, module 5 TOC. Okay, for the same question, like this question only, I think it was 1 power n, 2 power n. For that question, I solved for instantaneous descriptor also. Okay, so these three things you have to write, and you'll be easily able to score 12 marks. Okay, so don't miss this type of this question, very important one. Okay, Moving on to the last super important question, which is demonstrate the model of linear bounded automata. So LBA we have to explain, and here what is the main key points is you have to just remember, just make a diagram like this, and the ending will be like a tape here, and the ending will be dollar here, starting and ending state. Here it is constrained. Okay, the length is constrained here. It is not unlimited as in the Turing machine. Here it is constrained. Finite state control is there, and this is the read write thread, and moving right our head is moving to the right only. Okay, like that. It will always move to the right. Next. It will never move to the left. That is difference between TM and LBM. Okay, read write head, they will be having RN cells. The answers will be written here. Okay, means what are the values taken into input and from the given by input and taken from the output, that will be written here. And linear bounded automata is nothing but TM plus input constraint. There will be a constraint input, and in between that it will operate, and only it will move right. Okay, and this is a sample string here, A B B B A, and here all the rules of TM will be applied here. So few key points: it's defined by 7 tuples. It has 2 tapes. It is more powerful than PDA, and it can accept A power n, B power n, C power n. It is less powerful than TM. Okay, more powerful than this, but less powerful than TM. It does not come under non-deterministic or deterministic. It does not come under non-deterministic or deterministic. Okay, it is a separate concept. It is designed for context sensitive languages. Main key point. Okay, so this is the 7 tuples which is used to define. Two extra symbols are there. The this one, opening and closing one, are used as left hand and right hand marker, or you can use dollars also. Okay, and input lies between these markers as shown in this diagram. The input lies between these markers. Okay, so this is one question which is LBA. This is there in the 2024 model paper of BCS 503 2022 scheme. Okay, so don't miss this question. And one Turing machine question is there. For more such Turing machine question from the exam point of view, was the theory video of mine, module 5, and the definitions part. Okay, firstly, which I discussed, define Turing machine and working of Turing machine. Okay, so these are questions just solve. You can easily score more than 80% marks. And please do like and subscribe, share this video to your friends. And thank you so much for watching. I'll see you in the next one.